Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about introduction to the noise and thermal noise concept. And now here in this video, I am going to discuss about white noise or white Gaussian noise. So white noise is a thermal noise and the thermal noise is already discussed in my previous video. And what is thermal noise? The thermal noise is the random noise which is generated in a resistor on the resistive component of a complex impedance due to rapid and random motion of the molecules, atoms, and electrons as a result of the thermal energy. So that is the thermal noise. Once again, the thermal noise is the random noise which is generated in a resistor on the resistive component of a complex impedance due to rapid and random motion of the molecules or atoms and electrons as a result of the thermal energy. So now here white noise is a thermal noise whose frequency component extends from 0 to infinity. Consider a wide sense stationary thermal noise process N of t. It is called white noise if the power density spectrum or power spectral density of the random process N of t is a constant at all the frequency components. So this can be expressed as mathematically Sn of omega is equal to n naught by 2 for all frequency values, where n naught is the noise power, Sn of omega is the power density spectrum or power spectral density of the random process n of t, and this is the graphical representation of power spectral density of the thermal noise, and this is the graphical representation of power spectral density of the white noise. And what is the definition of the power spectral density? The power spectral density Sn of omega or Sxx of omega is equal to n naught by 2 for all frequencies. For all frequency means the range of the frequencies varies from minus infinity to plus infinity. So minus infinity to plus infinity, it has a constant value. That constant value is n naught by 2. The thermal noise in electronic systems is usually modulated as a wide Gaussian noise process. It is usually assumed that it has a zero mean, that is mu suffix x is equal to 0. Mu suffix x is the mean of the random process x of t. That mean of the random process is 0 and is Gaussian. The random process x of t or n of t is called a wide Gaussian noise process if x of t or n of t is a stationary Gaussian random process with zero mean, mu suffix x is equal to 0 and flat power spectral density. So that graphical representation as shown in here, that flat power spectral density graphical representation. So that is Sxx of omega is equal to n naught by 2 for all frequency values. The power density spectrum of a white noise is given by Sxx of omega is equal noise power divided by 2 into bandwidth. But we know that the noise power is k into Tb divided by 2b. So numerator and denominator bandwidth is the cancel. The remaining expression is kt by 2 watts per Hz. Since noise power N0 is equal to kt watts, the two-sided noise spectral density is given by Sxx of omega is equal k into t is the noise power. So Sxx of omega is equal to n naught by 2 for all the frequencies. So that is minus omega to 2 plus omega. The power spectral density of the random process stuff is a constant value. That constant value is n naught by 2. Next, find out the autocorrelation function. So, but we know that the autocorrelation function and auto power spectral density of the random process form a Fourier transform pair. That is, Fourier transform of power spectral density is equal Fourier transform of Four spectral density is equal Fourier transform of autocorrelation function. Four spectral density is equal Fourier transform of autocorrelation function. From that expression, the autocorrelation function is equal inverse Fourier transform of the four spectral density. So, but we know that here Sxx of omega is n naught by 2. Substitute that value into here. Inverse Fourier transform of n naught by 2. N naught by 2 is the constant that is written before. N naught by 2 into f inverse of 1. But we know that the Fourier transform of the impulse function is 1. Fourier transform of del of t is equal to 1. So f inverse of 1 is del of t. So now here what is the RHS term? F inverse of 1. So that f inverse of 1 is the impulse function, that is del of tau. So the autocorrelation function of the random process x of t is Rxx of tau is equal n naught by 2 into del of tau. So this is the concept of white noise or white Gaussian noise.